Okay. Well, where's our there it is. Good evening. Today we're gonna be playing with SpriteKit. Shaders is the goal is I want to learn a little bit more about another way to add some flair to our shapes library. With the first one is particle effects. The second way is through the use of shaders, and shaders are essentially another way to add effects to graphics, computer graphics. I was looking through the docs and I didn't see direct support for shaders in SwiftUI. However, there is support in SpriteKit, and SpriteKit is accessible in SwiftUI. So there's a couple layers that I might need to go through in order to take advantage of it. I happened to come across Hacking with Swift's tutorials made mention of something called Shader Kit. Looks like Paul made a whole bunch of these things in a library called Shader Kit, and so I was thinking of playing around with those today, just kind of learning a little bit. I know very little about shaders. I know that it's essentially code that's run on every vertex of a texture or of a of an image, every point, every pixel. That's the extent of my knowledge. I know that like there's a lot of different things you can do with them. I know that they're used extensively in a lot of computer games. And so gonna work on that today. That's our that's the agenda for today. And if things start to get a little bit crazy and we're not making any headway, then maybe we'll drop back and make some updates in our own shapes library, and maybe we'll do some gaming. I'm not sure, but that's the goal for today. So what I'm gonna do is I'm gonna take this code. Is there a Swift package for this? So Paul was nice enough to make this an MIT license, so you can grab it and do whatever you want with it. Use it. So copy this. I'm going to create a new. Well, maybe I'll just put it in the SpriteKit rules project. Maybe that's the best way to do this. So packages. Let's see. Add packages. I'm gonna. Let's search for it. Let's see if there's Okay, cool. Shader Kit. Looks like he's added Swift package supports. That's awesome. Oh, wait a second. Package resolution failed. Shader Kit could not be resolved. No package Swift manifest. Add anyway. This might not work. Uh-oh. We might have to just download it the old-fashioned way and import it into our project. I guess that's fine. Let's go ahead and can I remove that? Do package. I don't think it's going to resolve. Yeah, I don't think it's going to work. Oh, that's a bummer. Okay. All good. So we go back here and we're just going to download the zip. Let's just see what's going on here. Just open it up. All right, what you got for us? Let's see. App delegate. Okay, so we're using. So again, this is not SwiftUI. This is just Swift. And looks like we've got a game scene. So I'll maximize this real quick. There's a game view controller. Let's just run it and see what it looks like. Well, now. Oh. Okay. Let's see. What is it? What's it say in the fopen failed for data file, no such file or directory. Metal compiler warning, unused variable S. Writing typo. Okay. Adjusting the alpha. When you tap the screen, the test nodes will toggle between alpha 0 and alpha 1 for testing purposes. Oh. I see. Okay, so if we click on next, what happens? Oh, we got a checkerboard. And tapping the screen, I'm getting alpha has gone to 0 and to 1. Circle wave. That's fun. Circle wave blended. Rainbow. Circle wave rainbow blended. Color alpha, color non-alpha. Color invert. All right. Colorize, desaturate, emboss. Infrared, interlace. Ooh, I like that one. That's a cool effect. That interlace effect is what I wanted to use for a couple of the screens, the MGSV one in particular. Oh, this is fun. Very cool. Linear gradient, okay, we've done those. Pixelate, yes. This is the one I wanted to use for Celeste. Scan lines looks somewhat like interlace. Static gray noise, static rainbow noise, dynamic rain noise. Okay. Radial gradient, screen, water. Oh, that's a cool effect. Look at that. That is way cool. No shader. And we go back. What's the back button? Oh, we're just going. Oh, I see. Nice. Okay. So that is that's the demo. Now let's take a look at what's going on under the hood. All right. We have a game view controller. We have a title. We have navigation items for back and next, which do selector back tapped and next tapped. If let view equals self.view as skview, let the scene, file name game scene, which is this guy. And we set the scale mode to resize fill. And then we present the scene, ignores sibling order equals true. Preferred frames per second is 120, shows FPS true, shows node count true. And then just a bunch of auto rotate, supported interface orientations. And then scene previous shader, next shader, that's when the buttons are tapped. Toggle alpha, that's fine. Okay, let's go into the game scene. Let's go to the top. Wow, this was written like 4 years ago. Dang. 5 years ago. Okay, so type alias shader example equals title shader sk shader. So you've got an array of shaders, which are basically tuples of a title and shader. Current shader equals 0. Title equals sk label node. Sprite node image named Swift. Sprite node image named city. Those are in the app here. So the city image is this. The Swift image is this. It's got some transparency. Now this is nice because we're basically using this image to apply a shader to. Now, one of my my quests for using SwiftUI is to be able to provide like a dynamic image in the form of a SwiftUI view or a shape, so that I don't have to like have like a a stored image like in this project. We can take any old thing that we create dynamically and then like run a shader through it. That's the goal. So we've got a couple sprite nodes, and that just image names. So test node 1 and 2. Now in the game scene, first loads up, and then it did move to the SK view. We've got a background color, position, text, add title, add test node 1 and 2 with position. And then we're going to append a bunch of shaders, which looks like they've been created in a bunch of methods in here. Create pass-through, create checkerboard, etc. These are just the names of the, which I guess are shown on the screen. So circle wave blended, for example, is the title that's here for this particular shader. And then we set value of, what is this? Size, test node 1 size for attribute a underscore size. I'm not quite sure what that is. Load shader says let example equals shaders current shader. So taking whatever's in here. Title text is example title, which is the first part. Right, because it's a tuple that's named title and shader. That's fine. And then example.shader is the SK shader argument there. That's basically applying a shader to a node. So let's take a look at SK Sprite node. This is a class that's in SpriteKit. It is initialized with a texture. And then after you initialize it, you can apply, looks like a shader right here. Notice how there's no documentation in the actual file, but if we do an option left click, it says this is a text file that defines code that does custom per pixel drawing or colorization. The default value is nil, which means that the default behavior for sprite rendering is performed. SpriteKit implements many sprite features using a default shader, such as animations on alpha, SK texture filtering mode, and light from an SK light node. If you supply a custom value for the shader, your custom shader overrides the default shader, which neutralizes the default features. It is the responsibility of your custom shader to implement any of the features your sprites require. All right, pretty cool. So SK shader, what do you got for me? Defines the custom fragment shader, which can be set on a supported SpriteKit node. It's initialized with a source with a string, which is, I guess, the URL for that's stored in the project. So, for example, we've got a directory full of shaders. And there's a void main. Okay, so this is essentially a C function, right? It's a C method where you've got, I know that this is called for every pixel of a I guess the sprite node that's attached to. So what's he doing here? Let's take a look at the site again and see if he's got kind of a primer here following along. Open source collection of fragment shaders. For use in SpriteKit games, the shaders are designed to be easy to read and understand, even for relative beginners. That's us. That's me, at least. So you'll find each line of code is rephrased in plain English, as well as an overall explanation of the algorithm used at the top of each file. TLDR, if you use SpriteKit, you can add special effects from ShaderKit to add water ripples, spinning black holes, flashing lights, embossing, noise, gradients, and more, all done on the GPU for maximum speed. Tiny programs that operate on individual elements of a sprite's texture. They are sometimes called pixel shaders. It's not a wholly accurate name, but it does make them easier to understand. Effectively, a fragment shader gets run on every pixel in a texture and can transform that pixel however it wants. That might sound slow, but it isn't. Yay! All the fragment shaders here run at 60 frames per second on an iPhone 6 and newer, and 120 frames per second on an iPad Pro. The transformation process can recolor the pixel however it wants. Users can customize the process by passing fixed values into the shader, known as uniforms, and by assigning values to nodes that use the shader, known as attributes. SpriteKit also provides a few built-in values for us to work with, such as the texture coordinate for the pixel being modified and the current time. Gotcha. How are they written? Shaders are written in OpenGL ES2 shading language, GLSL. Okay, I said it was C. It looks like C, but it's actually OpenGL. Got it. Which is a simple, fast, and extremely efficient C-like language that is optimized for high-performance GPU operations. When you activate a shader in your app, it gets loaded and compiled at runtime, and in doing so, should be optimized for whatever device the user has. Okay, cool. Which means what that tells me is we can load things as needed. Well, we know that already because in the game view controller, when we click the back button or the next button, it just says, okay, scene, next shader, which basically says, okay, current shader plus equals 1 or current shader minus equals 1. if current shader equals -1, current shader equals shaders.count -1. Okay, so he's just making sure that whatever index is being modified, that it's actually a legitimate index in the array, and then says load shader. In which case, we just take the pre-made shaders. We say the shader equals example.shader. And when I say create pass-through, for example, what does that do? Oh. So it returns SK shader from file, shk pass-through. So SK shader from file is, whoops it easy. Okay. So basically just loading all of these files, all of these shaders into memory. And that's like the extent of the app. So the real secret sauce then is what is happening inside these shaders. I've got some, looks like established properties, or what, uniforms is what they're called, an SK uniform, which I guess is part of the SDK. Okay, so what else? SKH water. Water was like one that was that I found interesting. So what is this doing? This is saying it warps a textured node to create a water rippling effect. Note, this must be applied to something that has a texture. Oh, okay. And what are the uniforms? What are the variables that are... Let's see, what's that again? Uniform is a fixed value. So it's the same for every pixel. That's why it's called uniform, because it's the same. And by assigning values to nodes that use the shader, known as attributes. So I guess I'm wondering, what is the difference between a uniform and an attribute? Well, let's keep reading. Oh yeah. You'll find a main function, which is run when the shader activates. This must at some point assign a value to the predefined variable GL frag which represents the final color that will be used to draw the pixel. GLSL comes with a wide variety of built-in data types and functions, many of which operate on more than one data types. The data types are nice and simple. So we've got a bool, a float, a vec2, which is 2 components, a vec3 for 3, vec4 for 4. It's used to hold like RGB or RGBA, vec2s for like XY coordinates, and then void is to mark the main function as not returning a value. Shaders commonly move fluidly between float, vec2, vec3, and vec4 as needed. Functions used in ShaderKit. Okay, so a lot of math functions, so cosine, distance between two values. If you provide it with a pair vec2, you'll get the length of the vector created by subtracting one from the other. This always returns a single number no matter what data type you give it. Dot for dot product, floor, rounding down, fract returns the fractional component of a value. Okay. For example, fract 12.5 is 0.5. Min max mix. Smooth interpolation between two values based on a third value. Cool. Mod is the modulus function. Pow is like power to the sign. Smooth step and texture 2D. I don't know if that's all of them, but that's... Okay, it says here are the functions used in ShaderKit. Okay, so that's pretty much the extent of it. Texture 2D provides the color value of a texture at a specific location. This is most commonly used to read the current pixel's color. Technically, this reads texels, but it's easier to think about pixels while you are learning. All right. SK default shading. Cool. How long is this? This is it's quite a bit. Okay. So I wanted to know the difference between attributes and uniforms. So attributes and uniforms. However often you'll want to customize the way shaders work. A bit like passing in parameters to a function. Shaders are a little more complicated because these values need to be uploaded to the GPU, but the principle is the same as what? Passing in parameters to a function. Got it. ShaderKit uses two approaches for customizing shader behavior, uniforms and attributes. They're very similar, but the difference is that uniforms are attached to shaders and attributes are attached to nodes. Okay. Almost everything is declared as a uniform in ShaderKit. So if you want to customize the colors for your gradient, the strength of your water rippling, or the size of your interlacing lines, these are all specified as uniforms. So almost everything declared as a uniform. However, one thing is consistently specified as an attribute, which is node size. Node size. Okay. Some shaders require the size of the node they're operating on, and although this could be specified as a uniform, it would stop you from using the same shader on multiple nodes. Oh, I see. I think this is probably what's happening. This is probably what helps make it more efficient, is that you can apply the same shader to multiple nodes. Good evening, Compile Swift. How you doing? Yeah. Doing well. Just learning a little bit about how shaders work in SpriteKit, and just seeing how we can apply it to, hopefully apply it to SwiftUI. Awesome. Very cool. So I'm just kind of going through the shader kit, which is a library that is made possible from 2Straws or Hacking with Swift. And I'm just learning about how to use it. Seems pretty straightforward. They've got a lot of open source shaders that are available for use. And it seems like it's going to be relatively straightforward to use. Now, as far as like creating brand new ones, that might take some time, but I've yet to play with ShaderKit, so this will be very interesting. Nice. Yeah, I'm excited about it. I don't know what you've caught so far, but the example app that comes with this library shows a couple of the different, basically all of the shaders that are in use. So he's got two images, and basically these images are imported into SpriteKit as SK image nodes. I think that's right? Sorry, SK sprite nodes. So the images named Swift and City are in the test nodes, and then basically every time you apply a shader to that test node, you just say test node.shader is equal to this shader. So it's pretty simple, it looks like. I just jumped in the stream. Nice. So let me take you through a little bit of a tour here. So this is the checkerboard texture or shader. Circle wave. So it's create then apply. Yeah. Yeah, and that's what that's what these things look like. So for example, circle wave is just is created from this OpenGL code. It's a main function, and you apply to every pixel. You have to find essentially you're looking at the current color or whatever pixel you're messing with, and then if it's not transparent, you're going to apply some combination of math functions here to create some sort of effect here. And then the final color is you're multiplying, it looks like a gradient times your luma, brightness of the pixel. And then ultimately it just ends up like this, which is pretty cool. It looks like if in this rectangular region using the image, so the transparency, if the transparency is 0, or if the alpha is 0, then it's just going to use whatever it currently is. So it's not going to apply an effect to that particular image. Yeah. And then otherwise, and it looks like it's a function of time. So that's another thing that I'm very interested in. Where do you find the time? Looks like it's this value, u_time. I guess these are just kind of like, these are variables that are known to be part of the system. You just have to use them. So you take the time, whatever the current time is, you take the speed, multiply by 10, and then you that's how you calculate the wave speed. You have a brightness, which is a vector 3, which is the RGB of the brightness that's provided to you. Then we have how far our pixel is from the center of the circle. And the center of the circle is basically the distance between the V text coordinate and the U center. So I have the center of the image and whatever pixel we're working with. That's our pixel distance. And then we're able to use this pixel distance to determine the color strength, which is, looks like, what is it saying? We're cubing the distance from the center. So 1 minus the distance cubed. Multiply, and then this color strength, you're multiplying by the user's input strength. I'm not quite sure what that is. That's interesting. That doesn't, yeah, I don't know what that is. Is there nothing that Paul can't do? Seriously, that guy's got so many tutorials out there. I mean, he's been doing this for a while. This project was created back in 2017, so definitely has quite the library of projects to learn from. It's very cool that he's made this available for free. So that's really nice. We all get to stand on the shoulders of giants, you know. Hey, Dota 2 Attitude, the coding, it's going well. Learning shaders in SpriteKit today. How are you doing today? This circle wave here. I'm just going through the shader code and just seeing like how this is being applied. Wave density is the U density, which is, I'm not quite sure what that is. By the pixel distance, which has been calculated from the center of the image to whatever pixel it is. And then decide how dark the pixel should be. He does so much and shares so much with the communities. Yeah, most definitely. I always dive into his books and find something new. There's a lot to learn. And yeah, I really like his teaching style. He does a really good job. Which code editor is this? So this is Xcode. We're using the iOS simulator. Simulating an iPhone 13 Pro Max. This is SpriteKit that is that's rendering the images. Never tried Xcode. I use a lot of shortcuts. Aha. You know, Xcode is a fickle beast. It works until it doesn't. And it seems like with each new release, they add some cool stuff, but then some stuff gets broken. You know, half the time autocomplete doesn't work, which is very frustrating. But one of the cool features that came within the last couple of versions is not the canvas, yeah, what is this called? It's the preview basically. So for example, this project that we're working with called SpriteKit rules. Why doesn't it want to build? I might have a code error somewhere. Yes, renaming variables. Yes, most definitely. My last pull request had like 20 rename variable function requests. Oh gosh. Haha, said everyone everywhere. The Xcode is like the bear waiting to bite. Yeah, I know. You just, and half the time you gotta like restart it or delete derived data or whatever combination of voodoo magic to get the app to run. Are you very good at naming variables? Oh man, naming things is one of the hardest things for me to do. It's always so frustrating. Okay, what's the diagnostics here? Failed to build the scheme. Cannot find motion in scope. Oh, I see. We must not have added this in our... Oh, is it this? Wait, why is this... Really? Where am I asking for motion? Oh, in my emitter view? Oh, whoops-a-daisy. Okay, let's comment that out. All right. Now if I click resume, then it should work. So yeah, sometimes through user error, it's sometimes hard to find out why something's not building. Sometimes the error that gets sent to you though from Xcode is so cryptic, it's hard to find out what exactly is wrong with the project. Okay, so if we bring this up a little bit and we click on play. So this is something that we were doing, gosh, like a week or two ago. And what did we do? We decided to try, we're changing the texture color. Oh yeah, it looks like we broke it somehow. It's still looking at, oh, we wanted to make this an iPad, right? Yeah, that's what we wanted to do. So let's, I've been known to name something, come back a month later and forget what it's for. Are you me? My functions got smaller, so naming became more important. Ah, yep. Yeah, it helps if you're able to name something that basically self-documents, so you know exactly what it's for. Sometimes that's hard to do, though. I'm also kind of garbo at naming stuff. Yeah, I hear you. My theory is if I was meant to name it right the first time, they would not give me the refactor option on the menu. Yes, I think that's the universal curse of a developer is just learning how to name things. It's just so difficult sometimes. All right, so it looks like there's a is it a color multiply that's the issue? Or did I set this to be color? The texture is a Selenon with foreground color blue. Does that work? Oh no. Okay, it looks like we've I gotta figure this out. I know we had this working once upon a time, and then we set a value. We set some sort of a default value, and we were no longer able to see it. So this particle color we said was white. Blend mode was plus lighter. Oh, color is clear. What if we said that was red? Is that gonna do anything? Failed to build. This used to be like a starry night type of thing. Okay, let's see. Color. Okay, I already have color blue here. Texture, scale effect, blend mode, foreground color. Maybe I just take that off. Color multiply. No? Oh dear. Let's try this. Ah, here we go. That's what it was going on. So it wasn't animating because the value wasn't being supplied. Okay, okay. So this is our homegrown particle effect system. And this is in SwiftUI. So we're actually not using SpriteKit here. And the reason why is because my whole reason for like delving into this is I want to be able to create dynamic textures. I don't want to have to rely on PNG files to make my my textures. And SpriteKit relies on PNG files, on textures. So if you go back to this this project that that we're playing with here, this Swift icon, the Swift image, and this image of what is it? Just a city. That has to be stored in the app, right? Like you have to like pre-bundle that. What if you didn't want to do that? What if you wanted to download something, or if you wanted to like create like a dynamic shape and use that as the texture? Well, it seems like it's a little bit difficult to do that in SpriteKit, or at least I just haven't found out the way to do it yet. And so I'm hoping to kind of like create something similar to you know what we've seen in the particle editor, where we could do our own thing. And see, when I make adjustments here, this is where things get kind of crazy. Like I'm trying to mess with the scale, and you know, then we get this thing happening. So SVG is the answer, but I think they're bigger files or something. Yeah, SVG is great. Definitely is well, they're vector based, right? So you can make them as large or as small as you want to, without reducing the quality. So yeah, SVG is definitely a good way to go. I use it for icons. Yeah, I do love SVG for as many S's as I can now. Oh, it's amazing. Yeah, and it's friendly with your designers. Like if they're designing in Figma or in Sketch or whatever, and they can export it as SVG, that's like the best of both worlds, right? I found the emote for my code editing. Yes. Congratulations. Did you see the rotating one? Check this out. We just recently got animated emotes on the channel. Let's see if we can find it. Check out this one. This one's fun. I got your rename right here. Reaches for the hatchet. Cut it out. So we can mess with the texture color. And what does that do? That actually, what did that do? Now it's green. I don't understand why. Let's try to figure out why that's the case. I think I changed it from a clear color to, was it a blue color? Is that what I did? Yes, color. If I say clear, let's resume. Selenon leaves. Okay, here we go. So texture color, if I click on it and I go red, oh shoot, it still goes green. Oh, that's embarrassing. Okay, so something's happening. Color blue. What if I do that? Okay, so something is causing this to... Okay, so I said the foreground color was blue, but if I say the foreground color is white, then it starts out white. And if I can say, okay, now I want you to be yellow, for example. Okay, cool. This works. Green. Okay, cool. All right, so basically I need to enforce that my texture, which is just a shape, this is an emitter view that we created here. Let me go back up to what this is. This emitter view, where I've got a texture. I initialize my texture. It's just basically a generic where T is view, so it can be anything, right? Which means we can make something fun. We can say, oh, this is actually going to be, let's make it a kite with a point ratio of 0.7. And now they're kites. It's great that particle effects use so little resources on a device. We've come a long way in a short time. Yeah, there's been so many strides in the last decade. If you I just think about like the first iPhone that came out, you know, what, 2008, 2007, right? Was that around the time the first iPhone came out? And then what we have now, like, and back then we were using like OpenGL, like 1.0, I think it was. Apple switched to Metal, like what, a good 5, 6, 7 years ago, right? The funny thing is, like with SpriteKit, like you're using the GL shader language, so it's still like is there. I don't think that OpenGL is actually like all the way gone. They say Metal, but like Metal was mind blowing when they showed it the first time. Yeah, it was so cool. Okay, so scale and texture color we've got working. Makes it for some really fun animated backgrounds. I remember seeing the first game with Unreal Engine and couldn't believe it. Oh gosh, yeah. Such exciting time to be in. Yeah. There really is so much greatness that it's just uncanny, like the power that we can have like with mobile computing is so cool. All right, so that's this. So basically, if I wanted to, again, like, so my whole goal of this is to be able to, on the fly, create something that is, I want it to be accessible for people who want to use SwiftUI, but maybe not necessarily have to like worry about adding like a bunch of frameworks. Now, granted, you know, the use case for using particle effects, maybe it's only going to be in your launch screen, but if you are making a video game, it probably would be good to like just go into SpriteKit and just do it that way, since it's like a, you know, battle tested. But for like simple effects where you just want a little bit of flair, I think this is kind of something that I'm pursuing here. Now, if I get rid of the foreground color white modifier, then what happens? Okay, so this, I think this is the issue. First of all, maybe it's because the background color is black. Maybe that's what the reason is. Let's try setting the background color. What's happening here? Emitter view background color. Let's just say red. Okay, even if it's red, I cannot see the texture. It's like I have to give it a foreground color white, which is interesting to me that's the case. Maybe it's because the color is clear as a default. I think that's what it is. Yeah, I think that's what the problem is. Okay, so if instead I make my foreground color, let's see if we go back up here. And again, all of these emitter view properties are patterned after what you see in the SK emitter node in SpriteKit. So I just kind of, I'm actually using the exact same variable naming for this. Okay, let's see. Particle color equals dot white. We're using SwiftUI and SK emitter node. This is ignored if we're creating objects using the particle editor, where particle color sequence is used. Okay. Particle color blend factor, particle blend mode, alpha color. So yeah, I think this is probably where we get it, right? If I said blue, Oh, it still does it in white. This doesn't even matter. Wait, if I did blue here, and then I didn't do foreground color modifier. Whoops. X out. Hi, Animal. How you doing? Good to see you. Texture, scale effect, blend mode, foreground color, view model emitter properties, particle color. Okay, this is it. Emitter properties, particle color, which I have said. Yes. Okay. Now I can take out this foreground color, right? I can take this out. Good. Okay. So it's like I'm almost like for this particular thing, I wonder if maybe I need to set this as like an optional. You know what I'm saying? Maybe actually I don't even think I'm using this color property. I should take that out. Let's just take it out and see if it gets mad at us. You've been learning auto constraints? Oh, nice. What kind of a project are you working with it? Let's give that out of here. I don't think it uses color, does it? Yeah, it doesn't use color. Kind of fun using a visual editor as opposed to coding H-stacks and V-stacks. Oh yeah, it's way better. Way better. I agree. Okay, so duration, are we even using this? I don't even think we are. Here, let's wait. View model emitter properties duration. Oh, we are using duration. Okay, that's fine. Particle birth rate, particle lifetime. Oh, you know what we need to be doing? We need to do particle lifetime is what we need to be doing, I think. Particle lifetime. Time intervals, particle lifetime. Okay. That way I can get rid of this this duration property, which we don't really need. Okay. Good. Okay. Now the delay, I'm not quite so sure what to do with that. I know that we have been... Okay. I promise not to cry when I think about complete constraints. Nothing big, just the course I'm doing. Oh, right on. Sometimes it's fun just to kind of go through the process from a tutorial and just kind of just take it in and be like, okay, now I'm going to apply what I've learned. Let's see, delay. I see. I've done a delay. And then why do I do the delay? Let's take out the delay and see what that does. Oh, look at that. Kablam. Kablam. So here's something that I want to try. Well, I've already deviated from what I'm supposed to be doing today, which is I want to play with the shaders and see if I can attach that to a SwiftUI view. Constraints both on storyboards and in code are a great way to truly understand how views build themselves. Yeah, absolutely. The first time you drag from a storyboard to the code editor to hook it up is like magic. It really is. It's such a great feeling to like kind of for it to like click, you know? Yeah, I agree. So there is a particular shader that I wanted to play with, which was what was it? Well, there were a few. There were a few I wanted to play with. One was this water effect. This water effect looks really fun. So let's take a look at what that is. So the water effect, it's very small. Look at this code. This is just 2, 3, 4, 5, 6 statements. And what do we have going on here? Oh, let's Windows stay on top. Okay, so we say we bring both the speed and the strength into the kinds of ranges we need for this effect. So he's defining speed is equal to whatever time is provided and whatever speed is provided, but multiplied by some constant. And then saying the strength is equal to whatever the user strength is divided by 100. And then take a copy of the current texture coordinate so we can modify it. So we're saying some vec2 of coordinate is the current texture coordinate. Yeah, this is the shader Paul Hudson built. Yes. Learning code without the visual, it makes it hard to predict what will happen for beginners. Yeah. Yeah, the animation is awesome. It really is so cool. So we take a copy of the coordinate, and then we're going to do some sort of offset, and we're by a small amount in each direction based on the wave frequency and the wave strength. What? So sine of your coordinate x plus the speed times the frequency times the strength. What is the u frequency? Where is that even calculated? How do you get u frequency? What even is that? So coordinate x is going to be, you're going to add it to the sine of this argument. The y value is going to be the cosine of this argument, which is what makes the offset happen. And this is happening each frame. And then it says use the color at the offset location for our new pixel color. So the GL frag color equals texture 2D of U texture and coordinate multiplied by V color mix dot A. So again, none of these are actually defined in here. It looks like it's all happening in the engine itself. So what does he say at the top? It says this must be applied to something that has a texture. All right. So use speed. How many fast to make the water ripple? Ranges from 0.5 to 10 work best. Try starting with 3. Use strength. How pronounced the rippling effect should be. Ranges from 1 to 5 work best. Try starting with 3. Uniform. U frequency. How often ripples should be created. Ranges from 5 to 25 work best. Try starting with 10. Okay, so this makes sense. So he's saying that anything that's U underscore is a uniform, which is created at the time that the shader is being built. So U time, U speed, and U strength, and U frequency, and U texture. U speed, U strength, U frequency. Let's go to into our game scene, and let's go to create water. Let's see what this looks like. Okay. So we have we have 3 SK uniforms. Name U underscore speed, float 3. Name U strength, name U frequency. So these are defined, I guess, by the system. SK uniform is the name by which this will be referenced in a shader. Yes. The uniform type, the texture value, the float value. And yeah, not a whole lot in the API. Not a whole lot. Saying, hey, the name is this. I guess these are just... Where would one even go to like find this? I guess in the SpriteKit documentation, maybe? SK uniform. Ooh, a bunch of deprecated stuff. Uniform type property. Oh. Okay. SK shader does not support OpenGL extensions. SpriteKit will return an error if you compile a project containing a fragment shader using extensions. Okay. Whatever that means. Uniform named, executing shaders in metal OpenGL. Nope, not you, not you, not you, not you. All right, well. Basically, he is creating an array of SK uniforms. And giving it values, so float. And then saying, hey, make an SK shader from this file. That's SK water, that's this thing. And the uniforms are going to be this array of uniforms. And he's identifying speed, strength, and frequency, which we see here. Speed, strength, frequency. Okay. And then time, I guess that's just something that we get for free, apparently. Because I don't see that being it's not defined in this array, so maybe we just get that for free. I don't know. So here's what we're going to do. We're going to go back to our project, which is SpriteKit rules. And remember, we've got some stuff of our own, right? Like we've got some emitter. Let's see. We've made some particle effects with some assets that we already have in our project. So for example, we've got a few of our own stuff, right? We've got the coin, the Mora from Genshin. We have our rat hand emote. We have the Spark that comes with all SpriteKit projects. So this is like the default PNG file to use. Then we have our thick triangle boy that we also can play with. Why do we have both of these here? That's interesting. Let's try deleting Spark. Can I just throw this in here? Is that like a good idea? I don't even know. Because if I go to, let's see, if I go to my rain and I go to texture. Oh yeah, this is another problem. If you're using a PNG file and it's like gigantic, then it's going to be like what you see is what you get, and you're going to have to like mess with like a scale modifier. So everything you throw in here has to be like the right size, right? So our dummy thick triangles, we had to make sure that this was like 64 by 64, right? So what I want to do is I want to go to, for example, our game scene. We have our game scene, which is or no, it was a simple overlay. That's what I wanted to do. Let's click resume. Okay, so you'll recall maybe that what we had was here. I totally messed up a SpriteKit game by using PNGs larger than the screen space. The math was not happy. Yes. That's how you learn, right? You're like, oh, this is not what we're supposed to do. Oh, interesting. Did you see that? It was just added once. Show the change. Why did it only show up once? I think we just gave it it was just a single thing. Oh, did we make my Spark? Oh, I think I know what happened. We made our, oh yeah, it's only once per second. Is that why? So it's kind of fun because like we're using our own images, right? Like the goal obviously is for us to not have to like bundle our app with like a bunch of PNGs or SVGs. So back in our simple overlay, what we have is, again, this is our standard geometry reader wrapping a Z-stack. We have a circle right here that takes up the whole space. Our foreground color is purple. And then what we've done is we've overlaid a sprite view. This is, it takes in a scene, which is our simple particle scene, which is using SpriteKit. It gives us a size with the width and height as the dimension. Options allows transparency. So you can see the SwiftUI view underneath the overlay. Otherwise it would be like it would be opaque. Like if I did this, then you wouldn't be able to see what's underneath, right? The overlay, for example. So because we have that option to allow transparency, we can have this this particle effect on top of our SwiftUI view. I learned the other day that SK Sprite nodes have nearest neighbor type scalar, which keeps the pixel art nice and crisp. Oh, sweet. That's cool. Well, and then if you also add the, if you're going to be using a shader, to like pixelize like any other image, then that's kind of cool too. Okay, so we have our sprite view. We have our simple particle scene, which is just this. It's just a very, very simple scene did load. I don't think I even need this. Oh, this was just for me to understand that it keeps on getting like torn down and recreated like every time you actually do anything with the yeah, see that? It'll create a new one. I think for some reason it does it every time you offset in Y, but not when you offset in X, which I thought was interesting. Must be something to that. And the border is there just so that you can see like where the actual sprite view is. So in this, we said did move to view SK view. Then we say if let smoke equals SK emitter node, file named my spark. I mean, we could even just say my rain, just to show what happens. This should now show a continuous flowing array of Rouleau triangles. Now this emitter node we should be able to give it a shader, right? According to what we've seen in Paul's example, we can add a shader to this for extra coolness. So let's see if we can do that. I'm gonna go back into this old project. I'm actually gonna copy this entire shaders directory and throw it in here. We'll just put it underneath the assets there. Go ahead and copy items if needed. So now we have all the shaders, and we're going to go, so a shader on top of the SK emitter. Yeah, I know, this is going to be crazy. It may not work like what we hope, but we're going to give it a shot. We're just going to see how it looks. And then load a shader. What does it do? It says load. Yeah, we just say example.shader, which is shader's current shader, which is when we create water. This is what we do. I'm going to copy this and I'm going to throw it in here. Smoke shader equals create water from file SK water. Okay, let's see what that does. You guys ready for this? Wait, what? Return SK shader from file SK. Oh, you know what? This actually might be an older This actually might be an older SDK. Maybe that's why. Okay, what does it say? Incorrect argument label and call. Have from file uniforms expected source uniforms. Replace from file with source. Okay, let's try that. Is that going to work? Okay, let's try it. This is where Xcode takes a dive. I did not see a change. Let's press stop. And let's replay it. Yeah, it's hard to tell. They're moving very quickly. I kind of feel like there is something happening. It's hard to tell though. I don't think I'm seeing it either, yeah. It might just need to be just a static smoke position, particle position, shader. Let's try adding another node. Let node equals sk sprite node. File named coin. Add child node and node.position equals smoke.position and node.scale to CG size width is going to be, gosh, self.size.width times, let's just give it a quarter, self.size.height times 0.25, and then node.texture, or sorry, .shader equals smoke.shader. Maybe we don't even add smoke. Crank up the shader to an extreme. This should be it. Oh, maybe I'm not allowed to. You know what? I probably need to do this. Let's just add smoke. But then let's also say smoke.opacity. Wait, smoke dot. You can't even see it. Particle color equals dot clear. That didn't work. Maybe it just doesn't show in the preview. Oh, you might be right. That is a good point. That is a good point. Let's try this. Let's try but wait a minute. In our main, whoops. Simple overlay. Oh, okay. Oh yeah, we are showing this. Okay, let's give it a try. Let's try that. Maybe you're right. I'm never right. I only guess. Your guess is as good as mine. All right, let's see if it does anything. The moment of truth. Our node should be on top of this this raining money stuff. Raining ruler triangles. Oh, it's taking a while. Okay, let's see. thinking about it. Oh, here we go. That is not doing anything, you guys. That's okay. What if we, instead of the particle effects, we just try to get an actual image? Let's do that first. If let, and then I can do this. Add child node. Let me just take this out, and I'm not gonna have a shader, and I'm gonna say same thing. Okay. Now we should be able to see it. We've added a sprite node. Okay, we won't see the triangles. Ah, it is not there. Take out the node scale. Why? Why? Stacking order? Maybe. SK sprite node. File named coin. It's right here. How about emote rat hand? It's big, so maybe we would see it. Let's try it. Let's try emote rat hand. Nothing. Ah. Let's try building. Build failed. All right, let's put a breakpoint. Let's try it again. And just see if it's not finding it for some reason. That just seems kind of weird to me, though. Oh, it's not there. Shouldn't the node position type stuff be above the add child? Well, the order, I guess, doesn't matter, because if you you can add the child first, and then you can set its properties according to what we saw with our SK emitter node. So, yeah, it's failing to find the asset. Yeah. Image named. From your app bundle. Oh, let's see if this is actually in the bundle or not. Okay, yeah, it's there. It's in the target membership. So is coin. So is spark. So is thick triangle. I don't know why it thinks it doesn't exist, though. That's kind of odd, wouldn't you say? Let's try this again. We should be able to see it here. Guard is a great way to test something and fail fast before getting further in the code, in theory. Yeah. In theory. It's all fun and games. Yeah, it's not. Look at this. Not working. Ah. Image named? Oh, that's a good idea. Oh, this does not return. Oh, this isn't return an optional. Oh. Interesting. So it'll just do a runtime error if you can't. What, you just like throw it in a try catch or something maybe? Let's try this again. I usually just reference the asset name, not the file itself. Ah, there it is. There it is. Ah, there he is. Oh, yeah. Great job, Compile Swift. Thanks for the... that was just the wrong initializer I was using. Okay. So we should be able to scale this now. Let's just go step by step and just make sure that this is actually working. Oh, wait. I don't even actually need the simulator, do I? Okay, there it is. It's nice and big. But as you can see, because it's a rasterized image, it's kind of gross looking, right? When you scale it. This is the whole reason why I want to go to like an in-memory shape approach. That's my good code for the week. Time to mess up till Friday. Hey. With plenty of days in the week to spare. Nice work. All right, let's try adding the shader code and seeing what happens. Actually, cannot find smoke and scope. Oh, wait. Oh, never mind. Never mind. This was create water. I just want to see if it actually shows up in the preview. I don't see it making any changes though. It's not moving. It's not doing anything. You see that? It's not doing anything. Let's make it 0.5. Ugh. See, if you're trying to use a 64 by 64 image, you just get wrecked. Where'd you go, Sim? Is it possible it's applying the shader, but it's not running it? I'm not familiar enough with shaders. You know, that's a good question. We may need to activate it. Yeah, we may have to. Let's try this build and see if it does something. Error, unknown type name SHK water. Oh. SK shader, source SHK water. It does not, it can't find it. Oh, did I not even add this to the, oh, that'll be embarrassing. Oh, whoops, I did it again. Oops, I did. No, it says target membership is here. Wait, no. Click on the U. Everything is a part of the membership here. There is SHK water. There it is. Let node.filtering mode equal dot nearest. You looked up the code? Huh. Oh, look at this. What is this? Set value for attribute a underscore size. I wonder what that's happening. For crisp images? That's a great find, Yanimal. We'll add that too. It just says load shader. And there's really not much else, is there? Next shader toggle. Ah. Run action. No, this is just a fade in, fade out. That's not it. That's not it. That's not it. That's not it. Sorry, I'm scrolling really quickly here. Let's see. I wonder if I have to keep it in memory. Maybe it's not being stored in memory. Maybe. Add child. Set value. I'm just going to try this. What did you say? Node.filtering mode equals dot nearest. Node.filtering mode equals dot nearest. Okay, let's try that. Click resume. Silly question. I'm assuming you don't have to set the position of the shader. Oh, wouldn't that be something? You know, I'm not sure. Let's see. Value of type SK sprite node has no member. Filtering mode. Does that work? Oh shoot. Value of type SK shader has no member nearest. Huh, I'm gonna comment it out just for now. Argument passed a call that takes no arguments. Oh. What? I mean, this is an older project, so maybe that's the reason. What does this say? iOS 10? Apply before displaying? Maybe. It says it's on SK texture? Oh. Wait a minute. If that's the case, then we're saying image named Swift. So it's taking it from an image. Set value. Load shader. Just says that the shader is the shader. It's not actually setting the position of the shader. And you know what we might need to do is play with some of the values, like they were saying. Maybe it's because it's such a small image. You know what? Let's do this. Let's bring his image in here too. Let's see if we can recreate it. So let's go back to assets. Let's go to Swift. Yeah. We're gonna bring you into wait, whoops. Here, can I? Dagnabbit. Okay. Okay, we've added it, I think. Let's make sure it's there. Okay, it's here. It's here. Let's try using the Swift image because we know it works on that guy. We're going to go back to our simple overlay and we're going to take this out. Now I'm confused between SK sprite nodes and SK textures. Hey, Quicks, what's up? How you doing? How's your night going? How are ya? SK sprite nodes and SK textures. Yeah, yeah, there's definitely a difference. I'm not quite sure what the difference is. I guess you can have a sprite without a texture. It's good. It was with Benji for his birthday stream. Oh yeah, that's right. How did it go? SpriteKit's going well. We're just we're learning some cool stuff. We're trying to recreate this effect that was in a sample project where we can do this kind of cool like water looking effect that I'd like to apply to SwiftUI. So SpriteKit is using, you know, it's just SpriteKit, whereas SwiftUI can utilize SpriteKit. But right now we're only able to use it kind of like as an overlay to a SwiftUI view. I want to see if we can bridge that gap a little bit better, but I want to see if I can first recreate this in our own project. I think a sprite node is essentially a container for stuff. Okay, I see. It was fun. Okay, he was amazing in drag. Okay, awesome. Oh, I have to check out the VOD. Wait, does he store VODs? Was it a Dead by Daylight stream? Okay, cool. I'll have to check it out. He looked iconic. Nice. All right, let's see. Still nothing, you guys. Get this offset. Oh, I know what I was going to do. I was going to replace this with the Swift image. Okay. Wow, that looks much more crisp, right? So if I press play, nothing's happening. You guys. Game scene. I just want to see like where this is being called. Okay, so in the did move to, position is added, and that's fine. Set the value. Now this is the thing that I'm trying to wrap my head around. Wait. Let test. Oh, this is actually a stored property, you guys. Check this out. In the game scene, it's a let. That might be the key. Let's give this a try. Let's see. In my particle scene, I'm going to say let node equals SpriteKit node image Swift. So I'm going to get rid of this, and then in the did move to, I do that. So add the child. I set the position, I set the scale, and then I set the shader, and we should be good to go, I think. No. Why? 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 We're doing everything the same. We create the node. In the did move to, we say, we add the test. We've got the position. And then we load the shader and we say shader equals that. Right? And then afterwards we set the value. Maybe that's the issue. Maybe that's the issue. Okay, and then I know that it's gonna fail on this because it doesn't like this. Argument passed a call that takes no arguments. So just this? That doesn't make sense. Maybe that? What? Can I convert value type CG size to expected argument type SK attribute value? Well, how do I live without you? Attribute value. equals sk attribute value. Float node dot size. Oh shoot, wait a second. It doesn't have, there's no size? Wait, oh, no, wait. Vector float 2. I don't know if this is going to work, but we'll try it. See if that builds. Yeah, Quicks, I'm trying to add the wavy effect. But it doesn't want me to. Okay, fix. Let's convert you to a float. And, oh, whoopsie daisy. Oh, I hate when it does this. Okay, build again. And then fix again. Yep. Wait, you didn't do it. Okay. Build. Yeah, I'm trying to add the wavy effect and it's not working yet. It should be fine. This is just a... Now, what we're supposing is that it's not actually being able to show up in the preview. Like we actually have to build it to a simulator to see the effect. That's what we're hoping. I'm a little concerned that I can't see it in the sim. Okay, come on. Oh, no. Wait a minute. Unknown type name SHK water. Program source error. Expected unqualified ID SHK water. So that's a thing. What is it about this shader kit example? Is there, let's see if there's anything else in the file that, or in the project that actually maybe defines those. Maybe that's what's going on. Let's see. Yes. Shader kit extensions. Oh, how could I miss this? No. SK uniform from an SK color. Wait, are they even using this? Oh, this might be it. Convenience initializers to create an SK uniform from a CG size. Okay, I'm gonna throw that in here just in case. So yoink. SH water typo perhaps. SK water. Maybe. This says return SK shader, which the source is SHK water. And this is SHK water. Yeah. That's the file. It's not finding it. Debug shows the shader is actually attached. Let's find out. I think it is. I'm pretty sure it is. But yeah, that's a good idea. We should definitely go through it. In fact, okay, let's do this. So, play. Is it initializing the scene? Maybe it's static. It should be. Then again, here's the difference. The difference is we are using a sprite view that's initializing a simple particle scene. And I've noted, okay, check this out. Scene did load 1, scene did load 2. It's actually like recreating this multiple times. So I don't know if that has something to do with it. If it's like the whole like SwiftUI throwing away views? Could be. Let's just do this. PO node.shader. Nil. Yeah, it is kind of weird. Okay, so we've stepped through it, and now we say PO node shader. Okay, so optional sum, so it's there. And then set value, and good. Guys, it's not working. And there is not a second instance displayed over the first. Not that I'm aware of. Although that would be kind of weird, huh? Yeah, it's just doing an overlay, sprite views, scene, simple particle scene. Allows transparency, frame, border, offset, rotation effect. That's all. Maybe let's get rid of this rotation effect. I wonder if we need to like store a reference to the scene and just reuse that scene. Have you tested Paul's code before dropping it into your own project before I got here? Yeah, that's what this is, this sandbox. I just built his code from his project. And you're going through like all the different shader examples. So yeah, these are all working. This one's kind of fun too, this light grid. I like that a lot. It's not a SwiftUI stack order issue. I don't think so. This is what I want to use, the pixelate. Dynamic rain noise. Okay, where was it? Yeah, the water. Yeah, the water effect. So this is it, y'all. So yeah, the code works in this project, the shader kit example that he's provided. But again, this is running on, say that it says iOS 10 is the deployment. So I don't know, maybe it doesn't work on iOS 15. I'm not sure. Well, no, I guess that wouldn't make sense. I mean, it is running on a simulator that has iOS 15. It's just being built to the iOS 10 SDK. Yeah, it's working. What if I did this, you guys? What if I stored the simple particle scene not in a view? I think that might be what the issue is. But I don't know. I'm just grasping at straws here. Does SwiftUI update the SpriteKit scene continuously? Yes. In fact, if you take a look at this at the counter, check this out. This gets a little crazy. Every time I perform an offset to the overlay, watch what happens. You're gonna get a what? Yeah, this also is a little bit alarming. But this scene did load. This is a static property, or we say our count for the number of particle scenes that get created. We say scene simple particle scene.count plus equals 1, and then we print every time a scene did load. Watch what happens when I offset in Y. Oh, just kidding. Oh yeah, here we go. Look at that. Look at that madness. Every time I do offset, look at this. Scene did load, like, because it's a view modifier, right? So every time I change the offset, it's going to recreate the scene, which sucks. What that means is what I probably need to do is make this be like a, maybe I make this a state object. No, not you. Hold on a second. Let's go back to, I think this might help actually. So state object, private var, scene equals simple particle scene. Yeah. Oh, nuts. I just realized Wait, hold on. No, this is okay. This is okay. Let's go back. Size is CG size with dim times height dim. Yeah, so essentially when the geometry reader first gets created, the scene is initialized by a size, right? I don't know how to do that without did move to view. But I think there might be something here. So like rather than, let's just say size, I mean, I don't know. Let's just try this. Let's just try width is 800, height 800. Just for kicks, just for laughs, just for guffaws. Oh man, it's okay, Quicks. No worries. Thanks for stopping by. I hope you have good work tomorrow. Get plenty of rest. Hey, that's a cool looking emote you got there. Okay. So I'm going to try to just create this once. And generic, wait. Then maybe I can do this. Then I can just say scene is scene. That way it only has to get created once. Maybe? Komodo hype. Good times, good times. All right, so maybe this is the solution. Although, wait a second, it doesn't like this. Generic struct state object requires that simple particle scene conform to observable object. Oh no. What have I done? Let's just make it a private var, I guess. Fine. Be that way. Actually, can't you create like at state properties that are technically objects? How it loves to always bring up observable objects. I know, right? You forgot to do the thing. Shoot. Okay, let's see. Let's see if this actually fixes it. All right, build. Oh, whoops. I'm looking at the sorry. Let's build from the simulator. I thought I done told you to build the simulator. Now this should only do scene did load once. Cool. So basically it's not getting redrawn, which is amazing, you guys. You know what that means? Isn't at state for updating across scenes? Yes. It will so basically all these variables, they don't get recreated every time simple overlay is recreated. In fact, I wonder, do I just do that? Do I just say state? And will it like get mad at me? Let's just see. Let's just see if that works. It can also just tell the current scene to redraw if state changes. Yeah, that's true. But I was noticing like every time, like when we didn't have this, when we were basically recreating the scene every time, that you could see like the particle effects were like redrawing. In fact, let's see if that actually fixed it. So now I could do this. I can uncomment the smoke. So you should be able to see it behind it. Wait a second. Why is smoke Z index above the Swift image? Why? Let's fix that right quick. The plot thickens. Okay. Now it's working. Now if I offset, it's not getting recreated. So like the particles or the particle effects are constant. They're not getting reset every time. That's good. So what did we learn? What did we learn so far? We learned that keep a single reference so the scene isn't recreated every time view modifier changes. Yeah, nice. Sadly, the smoke doesn't thicken. Yes, that is still not. We're still without a wavy effect, and you know, we'll get there though. I think we'll get there. Now, you know, what would be a good thing to try is when you first load this up, like when you first load this up, it basically starts with no shader. It's only when you press the next button that it then applies another shader. So I wonder if like when it first loads then you need to do something to it in order for it to you know what I mean? Maybe it needs to like be fully loaded before it can apply a shader effect. I don't know. Maybe we can do something like, well, wait, and it did move to in the other project. Let's just take a look at what that does. And the did move to, no, it applies, it loads a shader and it applies it. It may be that because the current shader is a create a pass through, which is, oh, from file pass through. Oh no, it's applying a shader still. But what if we did this? This will be I'm gonna do this instead. Instead of pass through, I'm gonna say pixelate, because I want to see if my hunch is right. If it loads, and if it's pixelated, then I'm wrong. Look at that. Look at that. It did not. Wait a second. Hold on. Nope. That's not right. That's not right. That's not right. Hold on. Return create pixelate. That's what we got to do. Okay. I don't want to get my hopes up. So this is going to, the create pass through is basically the same as the create pixelate. So if it shows up, then I'm wrong. Okay, it showed up. I'm wrong. So it should, when it loads, apply the shader correctly. So for some reason, it's just not doing it for us. Inserting English humor because I can't help myself. Yes. Take the opportunity. So obviously this is the pixelate shader. It's not the no shader. But what this is telling me is that when a scene is first created, it can still load a shader, which makes sense. Like, why would you have to take multiple steps to be able to like apply that? What I'm wondering is the fact that the sprite view is loading a scene preventing shaders from actually working? Like, are they basically just saying, no, you can't have a shader? Like, because if that were the case, I'd be really sad. A single tear would fall from my face. Let's get rid of the smoke shader. And Ah, what about this? What about this? What about this? Let shader, sk shader equals create water. Oh, shoot. I'll just make it a static function. Oh, wait. Is it capital self? Is that how we do this? Maybe, what about applying metal? Using the drawing group view modifier. Covariant self-type can't be referenced from a stored property initializer. Oh, are you serious? Okay, okay. Okay, hold on. Just this then. Cannot override mutable property shader of type SK shader with covariant type SK shader. Oh, the scenes shader. Hold on. My shader. Okay, now let's do this. No.shader equals my shader. Maybe I have to store it in memory. Maybe the whole thing that made this work was the fact that he was storing each of these shaders in memory. Check it out. Like he's got an array of shaders. He's got an array of shaders here. In the did move to, he appends all of these shaders. They've already been here. You know what? That's it. That's got to be it. So if I store this in memory, then I can grab it. Oh, let's hope this is what it is. Yeah, they already exist before it's displayed. In the initializer or in the did move to, they've already built the shaders, they've loaded it up, and let me just try this. Just try this. All these smoke particles. He's using an array because he wants to show a whole bunch. Yeah, that's right. We just want one. Yeah, that waving thing is not happening. Okay, here's the moment of truth. Now we have this simple particle scene, and when it did moves, it grabs everything here. If we were to build an app that was just like his, we should be able to see let me just make sure that there's no other things in here that I'm missing. No. Game view controller. Wait, let's look at the game view controller. Maybe there's something magical in here. View did load. Set the scale mode to fit the window. Present the scene. Should auto rotate. Support no. No. I don't see anything else that would cause it to be okay, so back in our project, our app main is our SpriteKit rules app. But if we were to like instead make it here and use what, game scene? Oh. Somebody get Paul on the phone. It's about 6 in the morning. How to load before the scene. Above did move to view. Maybe a custom initializer. I mean, maybe. I didn't see a custom initializer here in the game scene. There is no custom in it. There's just did move to. There's no custom initializer. So that's not what's happening. Game view controller. Main. Oh, the main storyboard. Okay, what's happening in the storyboard? Anything special? Probably not. Probably not. If main interface is main, what does main look like? Ah, game view controller scene. Yep. This is it. Okay. So if I were to, again, press play, what this should do is, oh, I have a duplicate symbol. I have a duplicate main. Hold on. Get rid of the at main here. So it's not going to do simple overlay. It's just going to do our game scene. This is going to be, yeah, this is our old stuff. So now if I replace this with our simple scene instead, so game view controller is basically this. But now if I say if let scene equals sk scene file name, wait, hold on. File name game scene. And then we're doing this. Wait, how did he do it? Go back. Game scene. Load the SK scene from game scene.sks. And then essentially game scene looks for something that's named the same thing, right? So all I have to do is just rename this. I could say, this is my game scene old. What does game scene look like here? See, there's nothing here in the scene. That's fine. And then when I go to simple overlay, I can call this simple particle scene, I think. Let's see. Game view controller, simple particle scene. Let's try that. I should see the Swift file. What? Just kidding. What's happening here? What is happening here? Game view controller loading a scene with a file named simple particle scene. Oh, I think this is the issue. I think the issue is it still needs to be game scene.sks. It still needs to be game scene.sks. I'm going to name this game scene old. And then I'm going to recreate, I'm going to go back to simple overlay and I'm going to call this game scene. You know, that might be it. That might be what's going on. Game scene. Game scene. You're going to build? Okay, let's try this again. So I've renamed my simple overlay scene to game scene. And hopefully all the wires are still working so that I can see SpriteKit game scene by itself and not like be an overlay of a SwiftUI view. And hopefully, oh, build failed. Cannot find simple particles. Oh, shoot. Oh, shoot. I forgot this. Okay. Did it work? Okay. All right. Something is not working. Something is not working, you guys. But hey, you know what? When we get to the bottom of this, it's just going to be so cool when it does work. I'll be so happy. But for now, we got to figure out what's happening here. I think this is actually, I think you know what the main problem is? We're seeing this SHK water, unknown type name. I think, you know, and you alluded to it earlier, I think. Was it you, Compile Swift? About what we're seeing in here. Unknown type name. Yeah, the SK shader failed to compile. That's, hey, when in doubt, look in the console, in the debug console. It'll tell you what's happening. You think it's a typo? Oh my gosh, if that's what it is. SHK water. SHK water. Like, that's the name. SHK water, right? So why does it refuse? Why? Not you. No dot extension. Yeah, I think. Because it didn't do that in the old one. Remember, I just copied and pasted from the old project. SK shader source SHK water. Ah, wait a second. Wait a minute. This one is from file. But it didn't like the from file. So for example, open the developer documentation. The from file file named. Oh. File named. It's file named. Source. But look at this. If you don't use uniforms, you're gonna have to add uniforms later. The source code for the shader. Oh, it's a string. It's a string. Oh, no. You guys. It's a string. 90 is right. It's a string. You guys. Oh, no. That's what it is. I can't believe it. Oh, no. This from file. This source, this is expecting, this initializer is expecting that this whole thing is like basically source code that can be parsed. I can't believe that. Hold on. Return SK shader. That if that's all it is. Yeah, like why? You've got to be kidding me. Attributes nil. Is that what I had to do? Oh my gosh, please say it. This is what it is. If that is what it is, then I will just be happy that we resolved the issue. Finally. Oh my gosh. That's all it was. Okay, so note to self. Source, if you're going to use this initializer, you better know why you're doing it. Okay. Now the moment of truth is, can we see this in our... well, we can go directly to simple overlay and just look at the preview. Maybe we can see it on the preview, which would be heaven if we could do this. Oh man, you guys, that was painful. I think the funny thing is you guys alluded to it, like, or like, hey, maybe it's a misspelling. And I'm like, no, it's spelled correctly. Not realizing, of course, that, first of all, when I copied and pasted this, it didn't compile for me. It's like I had to set nil attributes, which I don't understand why that's the case. But I'm just gonna, I'm just gonna let it go, and we're gonna take a look and see if we can see it in the preview. If we can see in the preview, then holy smoke, that'll be awesome. Oh my gosh, you guys. Just had that program. Oh my gosh, it's right there. It's right there. Look at it. Oh, glorious. We don't even need the simulator. And now we'll never forget it. Yep. Hey, that's pretty cool. Wow. Okay, so there it is as an overlay in a sprite view. Stupid strings, I know. Seriously. I'll try this again. I'm gonna take out the attributes nil and see if it like yells at me. Build. I'm gonna chalk it up to Xcode because the last time when I did like a copy paste, it said no on this return statement. I don't know why. And then I was like, oh, okay, we'll just do source, not even looking at the API. So that's definitely on me. But yeah, we don't even need this. If it's an optional, then that makes sense. Okay. Well, that's cool. Good to know. And look, I think we're even getting the effect on these on the rain. Can you see it? It's very difficult to see, but it's actually happening. The wavy stuff It's actually showing up on the triangles too. They're going very quickly, but you can see them morphing if you look hard enough. So it is happening. Right on. That's cool. Yeah, it's applying to all the children. Yeah. Isn't that fun? In which case, what we could do is yeah, you can see it like over time. Like if I track, maybe if all I have to do is change the Maya rain to be whoops, oh, yep. Hold on. I always pick the wrong menu. If I change the speed on this guy to be let's see the speed, let's say let's put it in half, so 170. So yeah, now it's going much slower. And then we go back to emitter view. No. Sorry. Where are we at? Simple overlay. Now you should be able to see it easier. Yeah, you can see him changing over time. Behold the power of shaders. Now, what's our next step? Can we apply this to a SwiftUI view in memory that then gets like ported into an SK emitter node as data? Well done, shaders. Okay, now that we've done that, let's do another one. Let's make another one. This will be fun. Scan lines. What does scan lines look like again? I should just grab like the whole, like all of this. Create scan lines. Or no, I wanted the pixelate, didn't I? Yeah, I wanted the pixelate. So I had made a couple of assertions while we were debugging this. One was I needed to keep this shader in memory. I don't know if that's true or not. So let's just see. First of all, let's change this to pixelate. What the heck? What's happening? Hold on. It does not like that. Very interesting. So that effect doesn't work very well for 64 by 64 images. At least for these settings. Maybe we can make it a little bit better. Where is the create pixelate? Use strength float 8, A size vector float 2. You know what though? I think the reason for that might be we're using the same shader on different Yeah, maybe I need to do that for here for a underscore size, because for create pixelate, let's do that here. Smoke shader, smoke set value, attribute value for attribute a size. Wait, and attribute value was this. Smoke. I'm saying smoke. It's not smoke. It's like rain. Can we separate the SpriteKit view into multiple views, each with their own shader? Yeah, that's the goal. Look at this. Look how it refuses to. Ah. So the SpriteKit node. Yeah, no worries. Thanks for chilling with us, Animal. Have a great day at work. We'll see you next time. This attribute value for the SK emitter node does not have a size. SK emitter node does not have a size, in which case, well, it's an SK node. Well, shouldn't all SK nodes have a size? It has a frame, which is a getter. You can't set it. Oh, no, wait. You can set it, can't you? That's an open var. You can set attributes, can be used with custom SK shaders. Oh, deprecated. Attributes are only available for node classes that are supporting SK shader. See SK sprite node. Wait a minute. No, you're a sprite node though. No, you're an emitter node. Just kidding. Okay, so this isn't going to work. In which case, let's mess with the pixelate values. What did he say was a good choice for that? Let's go back to the pixelate shader code. I think he had made some recommendations. Oh gosh, okay. Yeah, surely you should be able to set something. Let's see. We get passed in the size of the node being transformed, for example, 100 by 100. Our texture coordinates are specified as a range from 0 to 1. So if we divide 1 by our size, we get 0.01 squared. We can multiply that by the strength. Once we pixelated size, we can divide our texture coordinate by that number. Divide that by, pass the number to the floor to round it down. It's really this algorithm should use round rather than floor, but GLSL does not have a round function. Instead, a simple replacement is to use floor, some number plus 0.5 instead. Yes, that's the same effect as round. Okay. Doesn't say like, okay, let's see. Ranges from 2 to 50 work best. Try starting with 5. Okay, so I could say, if we go back to our code and we say, listen here, simple overlay. If we make our, see, Xcode just can't catch up. If we say up at the top, where are you? Create pixels. Yeah, if we make our let's start with 5 and see if that actually works for smaller images. I think that's the catch, is that you've got a small image. Hold on. Ah, you see how it's not as pixelated now with a lower value. Let's see, and then it just goes weird. Okay, how does this look in an actual simulator? Let's give it a shot. I wonder if like where are you at, Sim? Oh, it says the build failed. Why does it keep saying the build fails? Okay. Oh, settle down there. Come on now. Come on, let's not get all uppity. All right, here we go. Just play. Still failing. Why are you failing? This is why I can't trust Xcode, because I build it, then it succeeds. So then I try to build and run. Yeah, it's finicky. It's okay. All right. How does this look on an actual sim? Oh dear. Yeah, that's not good. Something's happening there. What that tells me is that I need to either use like a more gigantic texture for pixelate to make a difference, or I'm just gonna need to mess with the strength here. Let's try 50 first of all. So the sim is showing similar effects to our preview. So what that tells me is that we can just stay in the preview mode to do our changes. Oh my gosh, you guys, what if we were able to create a SwiftUI control that actually like updated these values that we could then dynamically change the shaders? Did I set an X2 and X3 size? You know, I did not. I didn't do that. It should interpolate though, right? Even if you have like a 1X. Wouldn't that be something? We could do that. That'd be fun. Okay, so it's still being lame. Okay. And the Swift doesn't even look like a Swift anymore. It looks like a narwhal or something. And you know, that would make things really something. If we could update our shader on the fly, the pixelate shader on the fly, that would be really cool. It's a 1985 Swift. Like in Super NES Mario World, when you start the level and zooms out. Yes, Yanimal. Yes, absolutely. Hey, don't tell your boss you're still here. This one, okay, this is showing up well. So, but then this happens. Like, what is this about? That's weird. Oh, okay, guys. You're logging in. Time for me to drop another great stream. A lot of fun chat. Hey, thanks, Compile Swift. Thanks for hanging out with us. Thank you for helping me debug, because I was just going crazy. I was like, what is the deal? It's just a simple initializer. That was the problem. But hey, thanks for being here. Hope you have a great day. We'll see you next time. Meanwhile, we're gonna kind of play around to see if we can do some dynamic changes to our shaders with SwiftUI controls, which I don't know how practical that is, but hey, if we're just setting out to see what we can do. And then what would be really cool is if we could, my ultimate goal is to have the input be a SwiftUI view or a shape and not a PNG. Cause that would just rock. That would just rock. You know what I'm saying? Okay, so let's go 8. Eight seems to work well for just kidding, doesn't work well. Let's go 1. What I really want to know is why is it being all fussy with this and I think the reason is because the images are just so small. So you can combine earlier stream shapes with the SpriteKit shader. Yeah, that's the goal. Yeah, for sure. So basically everything it's in here. So instead of like a rouleau triangle, what if we wanted it to be, you know, a star polygon, for example? And then ultimately, if we go back here with our emitter view, like we're actually like creating our SwiftUI particle system, what if we were able to apply shaders to these guys? That's what I want to do. That's what I want to be able to do. Ultimately, this is and right. I mean, this is kind of a cool deal that we've got going on. Anyway, this is pretty neat, I think. Okay, guys, I'm gonna take a quick 2-minute break, and I'll be right back. So enjoy these fun particle effects, and be right back. BRB.
A few moments later.
All right, we're back. A few moments later. Okay. So we are making some pretty good progress today. So what I wanted to do next was see if we could dynamically modify the shader with a SwiftUI control. So let's go back to simple overlay. And I think the pixelate one was the one that was kind of like being crazy. So instead we're gonna go back to the water and see if we can make some changes to the strength of the water waves to see if that how well that responds. So let's do that. What we're going to do is we need to provide a way to like a function that says update wave strength. And this is going to be some float, maybe some CG float. And then what we're going to do is we're going to have to basically create water. But now we can say speed, which is float equals 3, strength, float equals 2.5, this is the defaults, and then frequency, also a float, is equal to 10. And then I can say float is speed, strength is strength, frequency is frequency. Let's see if that actually builds or if it gets mad at me. Uh-oh, beach ball. Uh-oh. Uh-oh. I think it's because I pressed the stop button while I was building. Oh no, not like this. It's not responding. I gotta force quit. Wah, wah. Okay. Oh, now I understand. Okay, so this SK uniform, you could name it anything you want. It's your uniform. This isn't something that's done by the system. Okay, that makes sense. You define your uniforms, and then in the code, it just makes an assumption that that variable exists. Is that right? Yeah, I think that's what's happening here. Okay, yeah, that makes sense. Okay, let's reopen Xcode. Okay, update wave strength. Cause yeah, as I'm thinking about this, like how else do you debug your shaders? Do you have to like compile every time and then just see what it looks like? Like what? Okay, so maybe this use case then is for us to like kind of like fine tune what our shader should look like. Not necessarily that we would be updating the shader in real time for a particular project because maybe it's expensive to do that. I don't know, but if you're trying to like find like the right effect to use, then I think that would be a good use case for this. So what we're gonna do is we're going to build and see this actually works. Okay, the build succeeded. The build failed. And then the build succeeded again. I mean, I don't know. Xcode, you just pick and choose whether you're gonna cooperate or not. It's really anyone's guess. Okay, so I've got the wave working. This is nice. I've got my offset, my overlay. So the scene is being stored. It's not being recreated. So the effect stays put. So that's good. So my next thing now is to say, hey man, let's update our wave strength. And how are we going to do that? Well, what we're going to do is we're going to say What we're gonna do? We're gonna say game scene dot create water. Say let shader equals create water, where the speed is going to be oh, you know what? I need three I need three attributes here. Update wave. We're just going to call update wave, where we're going to say speed, float, strength, float, frequency, float. And then speed is speed, strength is strength, frequency is frequency. And then I get to say self dot my shader equals shader. So we're, oh, is it a let though? It's a let. Flibberty gibbet. Because the SK shader, because it's a type of SK shader, you have to like recreate it the whole time, or each time. And then I'm gonna have to say, okay, wait. Bold. My shader equals shader, and then you know what I'm gonna have to do? I'm gonna have to do this. Var smoke. I'm still calling it smoke when the file is named myRain. I know it's weird. Let's just call it rain. Let's just call it emitter node. Emitter node. There. Okay. There we go. Now we can say in the did move to, we can say if let emitter node equal emitter node. There. Add child, emitter node. Boom, boom, boom. Okay, cool. Cool. We apply the shader already there, but then what we can do is we can say, we can do this again inside here. We can say self dot emitter node shader equals my shader. Cannot convert value of type CG float to expected argument. Oh, whoops a daisy. Oh, I meant for this to be a float. Yeah. You're okay. Okay. Now, here's where things get interesting, you guys. We're going to, now these top two sliders are just for the offset of the overlay. That's fine. But what I really want to do is make 3 more sliders, which will update the speed, the strength, and the frequency of the wave on the shader, thereby updating the shader and hopefully seeing some changes. So let's give it a shot. We're going to go back to, okay, so we got game scene here. We're going to scroll all the way down. I know it's all in the same file. It's kind of a mess, but we'll clean this up once we got things figured out. So now we're going to create some more variables. And this is going to be wave strength. We'll just say, gosh, I don't even know. What was the values? Let's see. Shaders for the wave, for the water. What do you say? Let's do this. Okay, cool. Go back to our file, and again, my apologies for the fast scrolling here. Okay, so wave, let's say speed, says ranges from 0.5 to 10 work best. So we'll start with 3. And then we'll do another one for wave strength. Try starting with 3. And then the wave frequency will start with 10. Cool. Now, let's do a groupo. We're going to do a slider. Is the index also going to be 1,000? Value is going to be wave speed. Oops. In closed range from 0.5 to 10.0. Cool. Same for wave strength, where it says, let's see, ranges from 1 to 5 work best. 1 to 5. And then wave frequency is going to be from 5 to 25. Cool. So now, because we've initialized the scene and the scene is always being redrawn, what we need to do is we need to observe changes to these slider values. So on change of wave speed, we're going to do this. We're going to say scene update wave, where the speed is going to be, we'll just say wave speed, strength is wave strength, and frequency is wave frequency. And I think this should work, although it might get frustrated with us because, oh wait, oh, that worked. Look at that. So on change of wave speed, but we're gonna have to do this for each of the values, wave strength and also wave frequency. Basically just says the same thing. Let's see how we do. Okay, we ready? Okay, the first thing we're going to change is the frequency. So we should be seeing faster movements. I think that's changing some things. If you look at the yeah, it is changing. Look at that. I moved it way up high. And then now, okay, I need to label these. Wave strength. Now I can make the strength crazier and the speed. Okay, that's changing a ton. For these smaller images, you're seeing a lot of activity going on. Wait a second. I just realized something. We're only updating this background. We're not updating the Swift. Oh shoot. Hold on a second. Whoopsie-daisy. It doesn't ripple faster. So yeah, that's the reason why is because I forgot to make a reference to our node. Ah, no, we already have it. There we go. So now we can say basically in yeah, there's just one shader. So this is the shader. The water shader is by itself. But we also have our two nodes. One is the Swift and one is the emitter node. One is the sprite node. And then I want to apply my shader, my updated shader, to each of the emitter node. So if I go update wave, now what I need to do is I need to say emitter node.shader is my shader, and then also node.shader equals my shader. And I think that should resolve the issue. Because yeah, I was only updating the shader of the rain essentially. So now, because I was like, why is this not changing? That's weird. Okay. Now we see the Swift, the big guy. Let's change the speed. Yep. 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 So there it goes. It's going crazy. Let's update the frequency. Oh, wow. Now it's getting really riled up. And then what is this? The strength? Okay, yeah, you can definitely see it updating in real time. So that's cool. That's fun. So SwiftUI controls that are modifying SpriteKit shaders in real time. And if we go super slow, I can be like, hey man, I just want things to be nice and chill. Just very simple water waves. Just kidding. The strength I think is the craziest one. I mean, it's a combination of like the three attributes, or no wait, uniforms. The 3 uniforms. Keep forgetting. Get this like crazy effect. That is like, it's almost unrecognizable now. It's like a tentacle or like moss, underwater moss, kelp. What? Meanwhile, these guys in the background are like, they don't know what they're doing. So anyway, that's pretty fun. In which case now we can look into the pixelate one, because that'd be kind of fun. And then, wow, we've covered a lot of ground today. This is really cool. Definitely need to clean up this project. It is a mess, you guys. It is. I know it's all over the place. I don't even have this like pushed on our on the repo yet, just because I'm so ashamed of it because of the current state of things. Oh man! But can you imagine being able to apply a shader to not just an image, but to like, well, even okay. So here's I think is the bridge that we need to take. Okay, so this works. So hooray, we've done it. Super, awesome. Then I can offset it off the page. Yay. The next thing is in my app. So my to-dos. To do. Convert a SwiftUI view or shape to a UI image or CG image that can be used to initialize a SpriteKit node. Right? So, for example, we have, if we go back to our simple overlay and we go to, where are we at? SK Sprite node image named Swift. Okay, so let's look at the initializers here in SK Sprite node. So you can initialize with an image or with a texture. Or with a color. So that's kind of cool. It does, and therefore, for a SpriteKit node, I mean, it makes sense that it's image data, right? So what about an SK texture? If I have an SK texture from data, so we have an image named, okay, from an image file. We have an initializer from a rectangular region inside an existing texture. We have initializer with vector noise with, okay. Here we go. With a CG image. image, CG image. So this is data. This is in-memory data. Look at this. Initializer with pixel data. So can I convert a SwiftUI view to data? Or by applying a CI filter to an existing one. Now, in the past, what did we do? Let's go back to our, I don't know if this is actually in it. I'm pretty sure it's somewhere. CI filter, are you in this project? Yeah, okay. MGSI droid view. Okay. Now I've switched projects here. And what I've done is I'm taking a look at, this is creating a UI image with a solid color in Swift. Okay, that's not what we're looking for. We're looking for CI filter. What did I do here? I don't think this even works yet. Load image, CI image equals CI image from an image. Okay. Process images from some context. It's a CG context with a CI filter. We are creating a UI image from the CGI image. And then when we process the image, then we're saying if let image equals image resizable scale to fill, where the definition of image is a SwiftUI image. Whoops. Hold on. And then what we say is image system name checkmark square, image system name, no. If let image equals image. When do I do that? Image equals image with a UI image of that. Okay, so we've already got it loaded into memory from an actual source image. This is not what I want. What I wanted to be able to do is convert my SwiftUI view to data. So let's take a look. I know I've searched for this before, but convert SwiftUI view to data, maybe even just data. Look at this. How to convert a SwiftUI view to hacking with Swift. All right, I've already looked at this before. How can I save a SwiftUI image to disk or get the data out? Convert SwiftUI view to image. Oh, this is newer. When I convert the display to an image, what kind of data? Image data. Data that's can be maybe even from like a CG context or like a UI image context. Yeah. When I convert the display to an image, the background object and the sticker size and position are messed up, even though I've made it neat and fit exactly what I want. The following is the result of the image. So what did this person do? So binding UI image. So geometry reader, VStack image, UI image, self effect data, model effect, image effect, resizable, scale to fit. Okay, they've already got UI image though. How do I convert a view to an existing? Okay, here we go. Convert view to image. Extension view. Take screenshot. Okay, this right here is the method that I saw also in the Hacking with Swift website. We basically say you take a UI window for some origin and size. You create a UI hosting controller with the root view as self. You say the hosting's views frame is the window frame. You add a subview, which is the hosting.view, and then you make key invisible. You return hosting view dot rendered image. That's an old code. I don't even know how to use it. Maybe there's another easier reference. Okay. Example. UI image right to save photos ammo. Yeah, they're okay, and rendered image is an extension on UI view where you're taking self bounds, graphics begin image context with options, let a context be equals UI graphics get current context, render the layer in the context, let the captured image be the get image from current image context, See this whole thing, like you have to like go into UI image and then come back out. And I'm pretty sure that if I go to this link, it's basically, yeah, it's this. It's doing the same thing. UI hosting controller. Although he's doing a few extra steps here. So I'm not exactly sure, because I actually did try this and I wasn't like the results. I wasn't able to use them. You can see the effect that he stores them in the images library, in the photos library. So when he clicks on that button or says to save to image, he's basically taking that view and then that gets saved like that, right? He's calling UI image right to save photos album. He's using the graphics image renderer, draw hierarchy after screen updates. Like, this is using a callback renderer.image, where that's a little bit different from what this guy's doing. Core data image conversion SwiftUI. That's like a couple of years old. How do I convert a view to an image in SwiftUI? This is the same link. Code Akuma. We can easily create an image from any view in UIKit, but SwiftUI views don't have this ability, so we need a way to work around it. Okay, so let's see what this guy has to say. Take screenshot. Okay, he's doing the exact same thing. After some research, I found a code snippet on GitHub that I could use. I copied it into a new SwiftUI project as a proof of concept, and it seemed to work perfectly. What is this code snippet that you're looking at? Sato Takeshi X. From Tokyo, Japan. Licensed under MIT. Nice. Hey, we like seeing this, right? Good on you. Thank you for contributing to the community. That's awesome. By the way, all our code is also MIT license. Just so you know, if you're wondering, the stuff that we've been creating here, you can see it in my GitHub, and everything also has the MIT license. So go ahead and use it. If you can make some cool stuff with it, I would just love to hear about it. So this is yeah. So this is very helpful. So if we can actually if this actually works, what are they doing here? Because it's this part. This seems to be the key. Let's see what's happening here. You get the image that is created by the button you tapped. That's not bad. I'm trying this code in Swift Playground, having some issue with graphics get current context is returning nil. Scroll view embedded inside a geometry reader. Content size of the scroll view has a height that is greater than the size of the geometry proxy. Okay. This used to work amazing. Since iOS 14, I get an error at self-layer.render in context. Attribute graph precondition failure. The app freezes and Xcode says the typical thread one signal board. Okay. Get a similar issue. The same issue, and that was last posted in October. So it looks like since iOS 14, this may not be working well. But let's go ahead and give it a shot. Let's again, we're licensed to do this. Let's just grab this real quick. And let's head on over to, let's see, what was it? SpriteKit rules. Let's create an extensions file. Let's do some cleanup here. Let's do what is it? Swift file. This is going to be UI view plus extensions. And we're gonna throw this here. And let's attribute Extension UI view. Okay, import UI kit. Extension view. Oh. Let's... I mean, I guess we could put them both in here. That's fine. So, rendered image. It provides us with a UI image, which is exactly what we need, right? To, wait a second. No, maybe not a UI image. Maybe it's, let's go back to, what was it? Is SK emitter node? No. It was SK texture, right? SK texture. Initialized from, initializers. Image named. Rectangle and existing. Oh yeah, we can initialize it from a UI image. Okay, so this will actually work. This will work. This will work. Okay. So we use it by let's go back to his code here and what does he say? He says take screenshot origin geometry in global origin. Where does the take screenshot go from? Self.take screenshot. So in the view, so the button action does this. You're taking a screenshot from self, which is this geometry rectangle. So and that's an action that you take. So that's a button. That's a button that's providing that. So any view can take a screenshot from the origin CG point size CG size, where they say origin is geometry frame and global origin size geometry.size. So having the geometry reader in there is key, because you have to have you have to create a UI window with a frame that's the same size as yourself. And views have to, the only way they can understand their own sizes is through a geometry reader. So that makes sense. Okay. So now, don't worry, we'll get there. We'll get there. This is gonna be fun. Okay. So if we say Okay. If I go to my simple overlay and oh gosh, I need to throw this game scene in its own class. I feel like, yeah, we definitely need to, because having this all in like one file is definitely a mess. I think I was trying to keep this game scene very simple so that I could show that, like, yeah, I could just do a simple overlay with this. And then what did we do? Yeah, let's clean up just a little bit. So, new group, we're going to make scenes. Shader kit extensions. Throw you in here. Now my scenes, this is a scene, but this is also like the emitter nodes. I guess I can throw those in. New group. Yeah, just cleaning up the project here just a little bit so that I can kind of make some sense of what's going on. Oh, did we miss the okay, there we go. New group, views. Okay, that's helping. All right. Now our simple overlay contains a scene, and we need to create a new scene file so that we can okay. Let's make sure it still can build. Okay, cool. There we go. Get a little more cleanup in our project here. Okay. Now for our simple overlay, keep sync. Okay, this is fine. Simple overlay is fine. Good. So in order for us to make sure that this works, what we're going to have to do is provide in game scene a way to update our image, our node, basically. So we're going to do a func saying update node image with and this is going to be UI image. Then we're going to say node equals sk. Wait, hold on. Let texture equals SpriteKit texture CG image. Wait, image. Is this an optional? No, it's not. Okay, cool. And then we say node. Okay, now I have to say var node. Then we say node equals sk sprite node with a texture. Right? And then we get to say node.shader equals my shader. Okay. That should be the key, right? As soon as we're able to get UI image, then we can be like, all right, I'm making a texture with that image. I'm making my sprite node with that texture, and I'm applying the shader to the node, and hopefully all will be well. So what I have to do is now I have to be like, okay, if we go back to our simple overlay, what I'm going to need to do is I'm going to have to create a button just so we can see if this works. Let's make a button here. And the filter mode equals nearest. Yes. Where do we put that again? In the is it the shader? Cannot infer contextual basis in reference to member nearest. Where you have the texture? Oh. Texture filtering mode? Like that? Nice. Okay, cool. All right, let's see if that works. And then so back to our simple overlay. Yikes. Let's see. We still have a couple of steps to take. The first step is we have to be like, we have to say in our, oh, I know what we can do. So var, view to image is some view. We have to be like, sprite view scene frame. Actually, no, this is okay. We can do this. We can say, button action label text image test button, and the action is going to be scene update node image. And what we're basically going to have to do is say, we're going to have to say, let view equals, we'll just say, Rulo dot Pentagon dot path in, we'll just say CG rectangle of 0, 0, width 200, height 200. So this is a path. Then we're going to say view dot snapshot. Wait, take snapshot, take screenshot. Origin is size is CG size. It's the same thing, isn't it? With 200. So I'm basically forcing a 200 by 200 path, taking a screenshot. And what does this do? Does this provides a UI image? Let image equals view take screenshot origin 0 size with 200 200. Scene update node image. Path dot fill color dot green. That should give us a view. The Rulo Pentagon filled with green. We take the screenshot, set it to 200 by 200, and then we update the node image. And then this should turn from a Swift to a Pentagon. You guys ready for this? Oh, I hope it works. And go. And go. And go. And go. Nuts. It's not working. Shoot. No. Oh, no. Okay. Hold on. Update. Okay. We're going to build on the simulator. See what we're doing wrong. We'll get there though. We'll get there. What time is it? Oh, it's almost time to go to bed. This may be to be continued. We're very close though. Okay. So oh, do we have to actually add? Do we have to remove the node and re-add it to the scene? Maybe that's the problem. Okay. Oh, just kidding. We can't do this now because here we have to go back. Hold on. Gonna go back to app delegate. Comment that out. Go to this and uncomment you. Okay, now let's do this. Image test. Okay. Let view equals Pentagon path with. Okay, I'm trying to step through. It might get mad at me because I'm stepping through view code. Yeah, I think it's actually. I think he's getting upset. Step over. Okay, view is. We'll take a look. Wait, I can't see it. It won't let me watch it. Oh, boo. Okay, then let's let image equals view take screenshot. Okay, now can I look at you? There it is. There it is. That's it. Guys, look at that. Look at that. Look at that. It's there. There is, it looks like there's a little bit of offset problem. Open with preview. So there is a little bit of an issue with the offset, but this is image as data. Oh, wait a second. Take screenshot. What does this do again? Return the hosting view rendered image. So it's returning a UI image. So the image is in memory, right? You're going, let's bring this in. So the UI image data is here. And then I'm saying update node image. So let's step in. So we've got our image. It's still there. Then I'm saying let texture equals texture with an image. So step through. And my texture is that. My texture filtering mode is nearest. Let's just take a look at what texture looks like still. Still looks like that. Then node is SK sprite node texture. Node. Now can I, oh shoot. Self.node. Can I view that? That's node. That's the node. Node.shader equals my shader. But it's not updating this. You know what I need? You know what I probably need to do? I probably need to say node remove from parent and then view add node, add child node. Wait, view.scene, add node, add child node. Let's try that. Maybe that'll be it. But it's looking pretty promising, you guys. So let's just see if that works. Okay, image, go. Okay, boom, and oh, you see it? It's in there. It's in there. You can't see it though, because it's hold on. Hold on. We were not able to actually like, hold on a second. Let's node remove from parent. Oh, wait. View scene remove node. Remove children in node. Let's try that. And then we have to say node.zindex, z position equals 1,000 again. Or no, let's make it 2,000. Just for sure. Yeah, particles are covering it up. Okay. I think I have to redo the whole position, right? I have to have to do this. Basically reset the whole thing. Yeah. Okay. Guys, this is huge. If we can do this. Oh, yes. Yes. Okay. Oh, okay. Okay. This is good. A couple things. We have a non-transparent background, which we need to fix. We also have some stuff that's getting clipped. But this is huge. Thanks, the animal. No, this is fun. I'm very excited about this. So we're bringing in SwiftUI on the fly. Which means, oh yeah, if we can get this working with a transparency, oh, that would be so cool. Let's see if we can do that. Maybe we can do that here. Let's go to our UI view extensions. And if we say hosting view.frame equals window.frame, window add subview, hosting.view, rendered image, where we say self layer render in context. Maybe we have to do this. Maybe we have to say our UI view. Maybe we have to say self.layer. Can we say background color equals none? Can we try that? Let's try that. Does this also mean that we can do this from the scene itself now? We don't have to actually do the simulator. Let's go back to the simulator. But no alpha. Yeah, I'm looking for no alpha on the background color. Yeah. Where was I? Simple overlay. Okay, I don't need the sim. Also, check this out. We're updating in real time. I mean, because, yeah, it just came from a texture, right? So now I'm just making this all crazy like. It's like a freaking amoeba now. Look at that. Okay. How do I change the alpha? If we go back to our UI view extensions, we say our rendered image. I say, maybe I have to do this before I render in context. Self.layer.background color equals none. Maybe self.background color equals clear. Let's try that. Let's try that. Window hosting view frame equals window.frame, window as view hosting.view, window make key invisible, return hosting view rendered image. Okay. So build that again. Then go to simple overlay. Okay. We did it, you guys. Although getting a little bit of, you know what I need? You know what I think we need? I think we need to Yanimal, my main issue is that I'm just lazy. That's the gist of it. And I so wish that I would just put this up. You know what I mean? In fact, maybe I should just do that. You know what I'll probably just do is post this entire stream to my YouTube channel just so that it's out there, and then I could like make a more polished version of it. This could be my course. It's true. This is wow, this is a real great breakthrough. Holy crap. There are courses with only 2.5 hours. Well, that is one of my goals for this year is to publish. So yeah, I think it's time. I think it's time to do it. I think we've got enough content, but with the the shapes and with the I mean, this is essentially I don't even need like this background circle anymore, right? We're applying shaders to SwiftUI views in real time. That's pretty dope. Just need to do a little bit of cleanup here, but I think we've got something good going on. Oh man, I'm really stoked about this. This is really fun. Now if we could just I mean, I don't even need, I could just say on appear this could happen. We don't even need the Swift thing on appear, and we could just say, yeah, boom, there we go. As soon as the thing appears, this is it. So I don't even need this circle. I don't need a foreground color. All I need is a sprite view, right? I don't even need this. Sprite view. Just like that. There it is. And of course, like I said, I mean, no man is an island. You know, we're all benefiting from the work of others that have paved the way for this. I feel like this is, you know, I'm able to add to what's already been provided to the community. Maybe, yeah, maybe this will be helpful to somebody. So, I mean, at least it's a fun thing to play with for sure. All right, let's play with. Oh, you know what we could do? Here's what we should do. Here's what we should do. We should assign one of these things instead of like the offset, because I don't need the offset anymore. This should be now like now I can give this a convex polygon sides int sides, and now this can be one of the in 1.0, no, 3.0, 20.0. And now it'll be integer value of X position. Excuse me. And now, oh no, that didn't work. X position, what are you doing? In 3 to 20? Why didn't that work anymore? Okay, we broke it. Hold on a second. We can fix this. It did not like. Convex polygon, path in rectangle, fill green. Does not like that. And then I can, oh yeah, when I change this drastically changes. Okay, let's figure this out. From X position, oh, I see. Let's do 3. That's the problem. Build failed. I may have to go back to our old thing and just see what's happening here. There may just be something that's causing an issue. Oh, I know why. Because we're doing offset. Don't do offset. There. That's it. We start out with a triangle. We move into other shapes, although it's not changing the shape now. What's happening there? Oh, I know why. Y does nothing because that's just the Y offset. On the change of wave speed, on appear. this is what we need to do. On change of X position, I just needed func. Make a drawable view with make drawable view. This is what I'll do. On change of X position, make drawable view. And the make drawable view is just going to be doing this. Control, make drawable view. And it's going to be that. And now, there we go. There it is. All right, friends. I am feeling pretty good about this. There is a little bit that I think I need to do, which is maybe add some offsets, or sorry, add some maybe some padding to the view so it doesn't get cut off. Because I'm feeling like the scale is getting cut off in here. So how might we do that? We could take a screenshot, origin 0, size, and we can make it even path. So for example, we could say path in a rectangle, 200 by 200, and our view is whatever it is, and then the image, we take the screenshot, the origin is again 0, size is let's make it 300 by 300. Maybe that might help. Whoops, I'm doing it in the wrong place. 300 by 300. And now let's do a border just so we can see color dot red. Interesting. I think that makes sense, right? Then as we get bigger, we can see where it's placed and relative to and see how it gets bigger, because the offset causes the issue. Now, if I comment this out, this, you can see at the very top, like if I get rid of like it's hard to see because of the triangles in behind. Let's go ahead and go back to I'm not going to add a child to the scene anymore. In fact, so I'm just going to close other tabs. Let's go back to simple overlay. And so now we should just see the Swift by itself. Now you can see if we zoom in that there are some effects towards the image that's causing, it's causing some side effects, which, oh, you lost the stream? Uh-oh. Try refreshing. All right. Why is it okay? It's making a drawable view. On up here, make drawable view. I'm not sure why it's doing that. Okay, let me know if you still can't see it. I'm sorry if it's going crazy. So you can see how it's being it's going 200 by 200, where the image taking a screenshot size 300. I wonder if this is if this isn't doing it correctly. The internet's fine. Oh well. Okay, well I'm definitely gonna publish this, you guys. I don't want to lose this. Twitch takes down, VODs after like 14 days or so. But I definitely want to publish this. I know it's a very long stream, but I'm gonna publish it to my channel, and that way we've got it for posterity. Definitely want to give a shout out to Hacking with Swift for the SpriteKit particle effects sample code, and to the programmer from Tokyo who had these really cool UI view extensions. Hey, how's it going? Thank you for the follow. There's a valve head spinning. Welcome. How you doing today? We're doing just fine. We're having a good time messing around with shaders in SpriteKit, and applying that to SwiftUI views, which is huge because what that means is that we can actually create in real time dynamic effects. So we've got a particle system that we're working on. If we can apply shaders to these particle effects, then wow, we've got a lot of fun things that we can apply to our SwiftUI apps. I'm doing fine just in Source SDK, making some TF2 maps and applying them to the workshop. Oh, sweet. That's awesome. What kind of maps do you like to put together? Gosh, man, TF2, that's a blast from the past. I loved playing that game. It's been a while since I played. It's been a few years. Very fun. Very cool. Yeah, so today we were just kind of messing around with some shader code that's open source. Trying to apply that to these custom shapes that we draw in SwiftUI, and seeing if we can utilize the sprite view that's accessible to SwiftUI in order to use SpriteKit to use the shaders. So the goal at the beginning of this stream was, can I form a bridge between SwiftUI and SpriteKit shaders? And we succeeded. So it's pretty exciting. Mostly it's 2-fort, but MVM combined with Manhattan. Nice. Oh man, I gotta reinstall that game and play a little bit. I'm getting a ping of nostalgia now. Yeah. Valve gave up on its development, so it's kind of it sucks right now. Oh man, yeah, that's too bad. I mean, is it? I guess it's not the moneymaker that it used to be. Well, I mean, isn't the economy for like the hats? Is that still going pretty strong? Or not so much? Like what with like the CS:GO skins and all that stuff? Yeah, yeah. Valve's still making the money. Oh gosh, yeah. I almost bought some stuff on the lunar sale. But I still have like a dozen games that I have not yet played that are waiting to play. And I was like, I can't like in good conscience spend any more on games until I finish the ones I've got. So Steam also is the process. Yeah, they got everything, man. They're the whole ecosystem, right? How long have you been doing custom maps? You found Undertale on Xbox Game Pass? Yeah, no, that's actually what I'm playing on. I'm using Xbox Game Pass to play Undertale. You've been going for 10 years? Oh, nice. So you got quite the portfolio then. That's pretty cool. Is Source SDK pretty friendly to work in? Has it evolved? I'm guessing you've probably seen some great updates in that amount of time. 10 years working on that, yeah. Hopefully the tool set's really good. Yanimal, you should totally play Undertale. I mean, yeah, with the Xbox Game Pass, it's like almost at this point, yeah, you can't not play it. And even if you didn't have it, it's like only like, or it was like only $3, I think, like a week ago. So looking really good for Gmob, but not really intoleted for a while because Valve forgot it. Dang, that's too bad. I wonder what the next thing. I mean, are they just kind of just focusing on their marketplace? Is that basically their main moneymaker, right? So you also bought Darkside's War Master for $5. Half-Life Alex. Oh yeah, that's true. Did you play that? Was that good? I do have a VR headset, but I haven't really messed with it much. I've got the Quest, the Oculus Quest. Is that even strong enough for this? You completed the game. Was it pretty good? I remember that a lot of people were blown away by like all the fluid physics, where they're just taking like bottles in the game and just kind of like dumping stuff out and swishing them around. You think it is? Okay, I should give it a shot. You can stream PC to Oculus Quest if you need more power. Steam Index works with it. Oh, I tried to get one of those. Yeah, I definitely want to give that a try. But with the Quest. So yeah, thanks to Sato Takeshi X for this awesome UI view extension. It's been around for a couple of years. So shout out to him for putting that together. This is definitely was one of the help. There's still a little bit that needs to be. It's still a little rough around the edges a bit. Create the context of the bitmap, self layer and context. Wait, maybe is this the same? Yeah. Rectangle.size false. I'm not even sure what these options are. I should probably look into it. But the main issue that I'm seeing right now in our simple overlay is that we're getting some clipping going on. So like I've got like the view with the border, and of course that's having the shader applied to it as well. So the border is kind of going crazy in real time. But I'd like this to be centered in it, and it's currently not centered. You need the first quest, not the second quest. Oh shoot, I don't have the first one. Would be a funny old man just plays a VR game. Yeah, well, you know, that's I just enjoy entertainment in all its forms. If I have the time to do it, you know what I mean. So yeah, this is pretty fun stuff. So we were able to create some dynamic shapes here, and again, this is just one text. This is just one shader effect that we're working with, which is the wavy stuff. I think those barriers are for the ragdolls for the source game. Oh, from Valve? Oh, cool. That's fun. That'd be fun to do a VR game on stream. If I could get it all set up. I do need to take a look at my current setup and fix this. So there's a couple of other shaders that I wanted to kind of mess with. And I think would be great. I think especially for our particle effect system, I think this would be really helpful to have shaders be involved in it, because the only issue that I can see is that the sprite view itself, if you're going to have one sprite view per particle, that might be a little bit expensive. But I want to be able to put like, so for example, you've got like an emitter node, and this is where things kind of overlap, right? Yeah, there's a border, but the only and I'm only showing the border as part of the view. Like if I were to, let's see, if I were to go back on our simple overlay, I'm just saying the border, if I said like line width, say like 10, I just made it just like ridiculously big. Whoops, extra arguments, line width and call. Oh, wait a second. Border. Here we go. Color.red width, let's say 20. Make it a big fatty border. And so you can see that it's like going crazy there. But I only did that just so that I could see like what the bounds were of the view. Interesting that doesn't reset when I change the value. Okay. Well, I think this is a good stopping point. I'm pretty bushed here, so we've got a lot done today. Again, I'm gonna upload this to YouTube. I don't upload very often, but I want to capture this. I don't want this to go away. I want to say, hey, I've got something here. Gonna make a polished version of it so that it can be like a quick, like 10-minute video, you know, of like how to put this together. But hey, thanks everybody for joining today. I'm gonna be back on Thursday night, starting at 8 o'clock Pacific time. We'll go to midnight. And who knows what we'll do. We might play a game, might do some music, might do some more of the programming stuff, but hey, stay tuned. And thanks everybody for the follows and for the kind words and for the encouragement. I really appreciate all of you. I had a good time today. I hope you did too. Take care everybody, and we'll see you next time. Bye-bye.